For T cells and B cells, if it's double-digit CDs, it's probably a B cell, single-digit T cell. There is, of course, one exception that we'll see in the hematology section. CD4s, of course, you gotta remember your helper T cells. CCR5, and you have the drug Maraviroch, which ends up binding to this. That's why it's important. This is for Epstein-Barr. And let's talk really quickly about pathogen-associated molecular proteins. Things like toll-like receptors and stuff. Macrophages end up looking for these things, binding to them. And although it's not a very specific thing, right? It's not like antibodies where you undergo somatic hypermutation and end up having super specific binding for different antigens. But it's still rather neat. And let's just quickly look at some of the downstream cascades that happens after binding to some toll-like receptors and stuff, and a quick way to remember it. So here you have some toll-like receptors, and obviously when everything gets bound to and activated, you have a kind of a different set of downstream effect. And of course it'll be different depending on the toll-like receptor, and you guys will go over in the student microbiology textbook. And if you don't, the BRS has an okay version of this. But the reason I circled this is just because it's really easy to remember. My date went to Iraq for sex trafficking. And it's hard to forget because it's pretty startling. This will kind of help you remember the downstream order of things. I've only seen a couple questions on it, but it was very useful when I remembered it this way because I wasn't able to get it wrong. And in fact, got it right. Back to this, CD16, CD56. CD56, you always think natural killer cells. And of course CD34 positive, hematopoietic stem cells. This is actually super huge now, especially with CRISPR and with pluripotent stem cells and stuff. The CD34 positive marker is used all the time just to differentiate between different types of cells and stuff, so it's pretty cool. And going back to it takes two to tango, the point that we made a few slides ago, where you absolutely needed not just the presentation, but you also needed the command afterwards. Because remember, if you're shown something but don't know what to do, it's worthless. But if you're told to do something with something, but you don't have it, well, then that's also worthless. So, just to show you, it does take two to tango. Passive versus active immunity. This is testable, but it's not like that difficult. The only difficult part is this right here. But there's nothing I can do for that. That's just, you just gotta remember that. IgA in breast milk, they love this. Maternal IgG crossing the placenta, they also love that. Remember, maternal IgG crossing the placenta, that's pretty big. The second time around, if you have any reactions between the fetus and the mother, especially if they have different rhesus factors, this is why you give RhoGAM after the first birth, because the next one's going to be IgG, and that will cross the placenta. That is just about it. Yeah. Alright, so not too much on this page that I can help with, unfortunately. Just remember to memorize everything, and whatever I could help with, I kind of highlighted and hopefully gave some cool mnemonics.